Welcome to MEI Modelling with Algorithms. We're on the topic of algorithms, sorting, packing and complexity of algorithms, and we're on to video 1.3, bin packing algorithms. So let's start by describing what the bin packing problem is. We're dealing with packing boxes of the same width but different heights into a series of bins. So this is what the problem sort of looks like. We've got a series of bins there, and these boxes A, B and C need to be packed into these bins. So we can assume here that the boxes are the correct width to fit inside the bins, and we're only considering the heights of the boxes. So we could start with a sort of common sense approach to this problem and just look for combinations of boxes that fit perfectly into one of the bins. So I could, for example, group these two boxes together, 4 and the 8, they add to 12, where if 12 is the maximum bin height in this case. So I could fit those into a box, no problem. Can I also make a 12 another way? Yes, here's another pair of boxes that make 12, and here's another pair of boxes that make 12, and then that leaves us with a 7 and a 5. Well, they also make 12. So if I pair the boxes up in that way, then that's definitely going to achieve what I'm setting out to achieve, which is to get all the boxes into as few bins as possible. The only problem with this approach, of course, is it's quite difficult to think about how we could describe what we've done there using an algorithm, certainly in a way which is going to be efficient. So if we were dealing with a much larger version of this problem, it could be difficult to take that approach. So what I'm going to do now is describe to you the first fit algorithm, which is a systematic way of doing it, which is easy to encode as an algorithm. And it's very simple. It's just a case of simply taking each box in turn and placing it into the first bin which has space for it. So box 1 can go in the first bin, box 2 will also go in the first bin, box 3 that has to go in the second bin, box 4 can also go in the second bin, and so on. Each time I'm doing this, I am checking the first bin, the second bin, the third bin to see if there's room. In this case, actually, the boxes are only ever going into the latest bin that's been used, but that's not necessarily always going to be the case. But that's a simple demonstration of the first fit algorithm. So what else can we say about the first fit algorithm? Well, it's a heuristic algorithm. What that means is that it's not guaranteed to give you the best solution, and you can actually see that in this case, because we know that it is possible to get all those bins into all those boxes into 4 bins, and the first fit algorithm has actually needed 5. So that's a slight drawback, but the advantage is it's easy to carry the algorithm out and it's easy to program it, but as we say, it can be inefficient. So what you might want to do is just pause your video for a moment and have a think if you can think of any obvious ways of improving on this without making the algorithm ridiculously complicated. Now, one way this can be done is to actually arrange the boxes into descending order of size before we go any further, like that. And this is called the first fit decreasing algorithm. Now, we're going to meet algorithms for sorting things in the next video, but let's assume for now that we can sort these into descending order. We then carry out the first fit algorithm in exactly the same way as before. So, putting each box into the first bin that is available to it. So very straightforward to begin with, like this. What I really want you to pay attention to is what happens at this point. We've got a box of size 4. It's tempting to think, oh well, that's going to go into there, but of course we must every time go back to the first bin and check that. It doesn't fit in there. Second bin, check that. It does fit in that one, like that, and then that box fits in there, and then actually that final box fits in the first bin. And so it turns out in this case certainly that the first fit algorithm has improved on things and actually has given us the best possible solution. That isn't guaranteed to happen every time, but it usually does improve on the first fit algorithm. So just a very quick summary of bin packing algorithms. One thing that we haven't mentioned, although hopefully this is obvious, is that this doesn't just apply to boxes and bins. It can apply to anything that is analogous to that as well. So you might see examples where you're cutting lengths of wood, or recording videos or parking vehicles in lanes, that sort of thing. There's all sorts of real life contexts in which the same algorithm can be applied. Now, as we've said, it's not guaranteed to give the optimal solution, and the first fit decreasing algorithm is usually better, but not always, than the first fit. And the thing which I've mentioned as well, and this is by far the most common mistake that I see people making when they're doing this, is forgetting this, that you must remember to check from the first bin onwards every time with each new item. So to finish off with, we're just going to look at a worked example. So here we have the masses of 11 items listed there, and they're to be packed in boxes that carry a maximum of 12 kilograms each. And we're going to start by doing it with the first fit algorithm, then we're going to do it with the first fit decreasing algorithm, and finally we're going to see if we can use our own common sense to find an improved solution still on that. So starting with the first fit algorithm, the first thing we're going to do is actually set out some rows or columns for our bins, like so. And so we're going to carry out the algorithm and put the first mass into the first bin. There's the 2 there. Next one is also a 2, well that clearly fits. Bear in mind we've got a maximum of 12, so next one is 3, so that fits into the first bin as well. And another 3 that will fit in. Let's just check where we're up to now. We've got a total of 10 now in that first bin. So the next mass, mass 4, that won't fit, so that's going to go into bin 2. Then we've got 4 that won't fit in bin 1, so let's check bin 2, it'll fit in there. Bin 2's now got a total of 8. Then this next mass 4, well that will fit in as well. Bin 2 is now full because that's got a total of 12. We've now got mass of 5, won't fit in bin 1, won't fit in bin 2, so that has to go into bin 3. Then a mass of 7, that won't fit in bin 1 or bin 2, it will just fit in bin 3. Bin 3 is now full. And then we've got another mass of 7, clearly it won't fit in any of these, so that's going to have to go into bin 4. And then the final mass, also 7, well that won't fit in anything, won't fit in bin 4 even, it's going to have to go in bin 5. So that is the result of the first fit algorithm. So now we're going to try and do this using the first fit decreasing algorithm. So this time we need to start by arranging these items into descending order, like so, and we've got our bins there ready as well, of course. So now if we carry out the first fit algorithm, the first item is 7, that will fit in the first bin. Next item won't fit in the first bin now, that will have to go into bin 2, and the third item won't fit in either of those, that will have to go into bin 3. Now the fourth item, this 5, check the first bin again, it does fit in the first bin. First bin is now full. This 4 won't fit in the first bin, but it will fit in the second bin. This 4 will fit in the third bin. Then we've got another 4, won't fit in there, won't fit in there, won't fit in there, so that's going to have to go into bin number 4. This massive 3 won't fit there, won't fit there, won't fit there, that will have to go into bin 4 as well. Same with this one, won't fit in any of those, that will go into bin 4. Bin 4's now got a total of 10, so when we get to this mass of 2, obviously again that won't fit in any of these. Bin 2 and bin 3 have got 11 in, so it won't fit, but it will just fit into bin 4. And then for this final item, won't fit in anything until bin 5, so we end up with a mass of 2 in bin 5. So what's happened here is that yes, we still needed to use 5 bins, but at least we've found that there's less going into the last bin. So it seems like it's getting towards an improvement. So the final part says, can we find an improved solution? So can we find a way of doing this where we're using less than 5 bins? Now there's no algorithm for this as such, other than the idea of us as human beings spotting sets of items which will fill a bin. So we're looking for groups of these numbers that have a total of 12. So, well, an obvious one would be a 5 and a 7. So how about if in bin 1 we put the 5 and the 7? What can we do next? well, we've got a couple of 7s left over. There aren't any more 5s, but we do have 2s and 3s here. So if I take a 2 and a 3 and one of these 7s, that will work, won't it? So I could have, say, 7, 3 and 2, and I can do the same thing for these ones as well. Another 7, 3 and 2. And luckily what that's left us with is these 3 4s, which of course also make a set of 12. So it is possible, as we can see here, to actually do this using just 4 bins. So that concludes bin packing algorithms. The next video will be sorting algorithms.